Hello everybody, welcome into another lesson. So today is basically going to be an algebra review day. We're going to talk about proportions today. Yesterday we talked about ratios, today we're going to talk about proportions. And this is very necessary because in the next lesson we start rolling this into geometry with similar polygons and similar triangles, which heavily involve the use of ratios and proportions. So let's start out with what are proportions. If we recall from algebra and pre-algebra and past courses, proportions are two ratios set equal to each other. And two ratios are only in proportion if and only if the left side is equal to the right side where they both have the same ratio. So you have your general form A over B equals C over D. But then we have an example here, 1/2 equals 2/4. Well, 1 to 2 is equal to 2 to 4 because 2 to 4 does reduce to 1 to 2. How you can check for that is you can multiply what's called the means and set it equal to the product of the extremes. So the 1 and 4 here are going to be your means. You take the product of the means, set that equal to the product of the extremes, which would be the 2 and 2. Those would be your extremes. So if we do that, 1 times 4 is 4. You set that equal to 2 times 2, which is also 4. If the left side equals the right, when you've done the cross product of the means and the extremes and set them equal to each other, then you have a true proportion. If the left side and the right don't equal up for their products, then the ratios are not in proportion. Let me illustrate with something, for example, here. Let's do 3/7 equal to 2/9. At first glance, it would look like a proportion, wouldn't it? Because you have two ratios set equal to each other. But take the product of the means, which would be the 3 and the 9, set that equal to the product of the extremes, which would be the 7 and the 2. So then what you would have is 3 times 9 is 27. You would set that equal to 7 times 2, which is 14. Well, 27 and 14 definitely are not equal. So 3/7 and 2/9 are not a true proportion because they're not equal. So that's how you would check to see if two ratios are in fact in proportion or not. Now, also we have some useful properties from algebra with proportions. Let's say I give you something like x over 4. I set that equal to 3/5. The goal is for these problems to find the value of x that would make these two ratios be in proportion to each other. So if we recall from algebra, you're going to take the cross product of the means, which would be x times 5, which would simply be 5x. You're going to set that equal to the product of the extremes, which is 4 times 3, that'd be 12. So 5x would equal 12, which then means that x would equal 12/5. And that would be your answer for x. So if you took 12/5 over 4, that would equal 3/5. And that would make these two ratios in proportion to each other. Let's do some more exercises like this. So I have 4 over x is set equal to 2/5. 4 to x is equal to 2 to 5. We have this proportion. Well, once again, take the product of your means, which would be 4 times 5, which is 20. Set that equal to the product of your extremes, which would be x times 2, or simply 2x, which would just give you then that x equals 10. So if x equals 10, then these two ratios would be in proportion to each other. All right, how about this one? We have 2/5 is equal to 3x over 7. So 2/5 is equal to 3x over 7. So once again, take the product of your means, which would be 2 times 7. That would be 14. That's going to equal the product of your extremes, which would be 5 times 3x. That'd be 15x. Well, then you solve for x. X would happen to equal 14/15. So when x is 14/15, these two ratios are in proportion. So yeah, today we're just going to kind of baha with some algebra exercises, but it's still very useful. Alright, this time we have 8 over x is equal to 2 over 5. Alright, so product of the means, which would be 8 times 5, that would equal 40. That'd be equal to the product of the extremes, which would be x times 2, or simply 2x. Solving for x, you get 20. So the value of x that would make these two ratios in proportion to each other would in fact be 20. Here's something different. So this time we have x plus 5 all over 4. That's going to equal 1 over 2, or 1/2. In this case, you still take the product of the means, which would be the quantity of, that'd be 2 times the quantity of x plus 5. That's going to equal 4 times 1, which would just be 4. Let's do the distributive property on the left. You get 2x plus 10 is equal to 4, which would then just give you that 2x equals negative 6, which would then have to give you that x is equal to negative 3. So the value of x that you should get would in fact be negative 3. Alright, we have x plus 3 all over 2 is equal to what? 2x, wait. It's equal to 4 over 3. I was looking at the wrong exercise. X plus 3 over 2 is equal to 4 over 3. So take the product of the means, that would be 3 times the quantity of x plus 3. You'll set that equal to the product of the extremes, which would be 2 times 4, so that'd be 8. Do the distributive property, you get 3x plus 9 is equal to 8, which would then end up giving you that 3x equals negative 1, which would then have to give you that x is equal to negative 1/3. So the solution in this case is going to be that x would end up being equal to negative 1/3. Okay, so a little bit different now. We have the quantity of x plus 2 over the quantity of x plus 3. That is equal to 4 over 5. Well, we should have done this in the past couple of exercises that had a variable in the denominator. Remember something, whenever you have a variable in the denominator, you first want to exclude any values of x that would give you a 0 in the denominator, because as we know, a 0 in the denominator would make the expression undefined, because you can't divide by 0. So if x equals negative 3, that's going to make this whole expression undefined. So we restrict it to where x is not equal to negative 3. If we get a solution of x equaling negative 3, we have to throw it out, because it would make it undefined. But nevertheless, take the product of the means, which would be 5 times the quantity of x plus 2, set that equal to the product of your extremes, which would be 4 times the quantity of x plus 3. Do the distributive on both sides, you would end up getting 5x plus 10 is equal to 4x plus 12. And then when you simplify this, you would end up just getting x is equal to 2. And x equals 2 is not an excluded value, so x equals 2 is the solution. It's a viable solution. And if you ever want to check your work, just plug your answer in for the x values and you should see that the ratios equal up. Alright, we have 2x plus 1 all over 4x minus 1. That ratio is set equal to 2/3. Alright, so once again, product of the means, which would be 3 times the quantity of 2x plus 1, set equal to the product of your extremes, which would be 2 times the quantity of 4x minus 1. That's going to give you, when you do the distributive, that'll give you 6x plus 3 is equal to 8x minus 2. And it just dawned on me, first we need to do an exclusion here. We need to exclude the value of x. Since we have it in the denominator, that'll make this expression undefined. So take your denominator, set it equal to 0. If 4x minus 1 equals 0, that means 4x would have to equal 1. Therefore, x would equal 1/4. X equals 1/4 would give you a denominator of 0. So x cannot equal 1/4. If we get that as a solution, we have to discard it because it would make a 0 in the denominator. Alright, but back to simplifying this. If you simplify 6x plus 3 equals 8x minus 2, you'll get negative 2x equals negative 5, which would then give you that x equals positive 5/2. And that is a viable solution. That's not an excluded solution, so x equals 5/2 is completely viable. And yes, sometimes you will get fractions in your denominator. You do have that sometimes. Alright, let's see. X plus 3 all over 2 is equal to 2x minus 1 all over 3. Good news is we have no x in the denominator. They're all in the numerator, so we don't have to restrict any values of x. We can get anything this time. So product of the means would be 3 times the quantity of x plus 3 equal to the product of the extremes, which would be 2 times the quantity of 2x minus 1. They're set equal to each other. Doing the distributive property, you get 3x plus 9 is equal to 4x minus 2, which when you simplify would give you negative x is equal to negative 11, which would have to mean that x is equal to positive 11. So the value of x that you should get is positive 11. Yep. All right. A couple more linear, then I have some quadratic ones we're going to do. Alright, so we have x plus 4 over x minus 4. That ratio is set equal to 6 over 5. And this time, in the left ratio, we do have an x expression in the denominator. So we have to take that denominator, set it equal to 0 to figure out what value of x we don't want, that we want to restrict. If we set x minus 4 equal to 0, that would give us x equals 4. So x cannot equal 4, because if it does, then you'll have this denominator being 0, making the expression undefined. So if we get a value of x being 4, we have to throw it out. So now take your means, the product of your means, which would be 5 times the quantity of x plus 4. Set that equal to the product of your extremes, which would be 6 times x minus 4. Do the distributive property, you'll get 5x plus 20 is equal to 6x minus 24. Which when you simplify this, you'll end up getting negative x equals negative 44, or x equals positive 44. So the value of x that you should get for this one is x equals 44, and that checks because it's not a restricted solution. And if you did get that restricted solution for your answer, then you would end up saying there's no solution. Because if you get it, that doesn't count. So 7 over 6x minus 4 is equal to 9 all over 4x plus 6. Okay, so this time we have both denominators have x expressions in them. So you got to take both denominators, set those equal to 0. If we set 6x minus 4 equal to 0, that's going to give us that 6x equals 4, which would simply give us that x equals 2/3. So right away, we know x cannot equal 2/3. That's not a viable solution, because if it equals 2/3, you'll get a 0 in this denominator, making the expression undefined. Then let's take the 4x plus 6, set that equal to 0. If you do that, you'll get 4x equals negative 6, which would simplify down into x equals negative 3/2, which means x cannot equal negative 3/2, because if x equals negative 3/2, this denominator equals 0. So x cannot equal 2/3 or negative 3/2. If we get either one of those as a solution, we have to discard it. So now take the product of your means, which would be 7 times the quantity of 4x plus 6. Set that equal to the product of your extremes, which would be 9 times the quantity of 6x minus 4. Now do your distributive property, you'll end up getting 28x plus 42 would be equal to 54x minus 36. Which, when we simplify this, oh boy, is this going to be fun. You'll end up getting negative 26x is equal to negative 78. Which, when you divide these, you'll actually end up getting that x is equal to positive 3. And positive 3 does fit because it's not a restricted solution. So x equals 3 is the solution to this proportion. All right. I have one more linear, then we got some quadratics. So I have 3x plus 5. That quantity to 3 is equal to 18x plus 5 to 7. Good news is we have no variables in either denominator, so there's nothing to restrict. We could get anything for x then, and it would be a solution. So take the product of your means, which would be 7 times the quantity of 3x plus 5. You'll set that equal to the product of your extremes, which would be 3 times the quantity of 18x plus 5. Now do your distributive property. You get 21x plus 35 is equal to 54x plus 15. Which now, when you simplify this, you'll end up getting negative 33x is going to be equal to negative 20, which then would just give you that x is equal to 20/33, which doesn't reduce any further. So the answer for x that you should get is that x equals positive 20/33. That one was not pretty, but that is the real world with proportions. All right, let's do a few quadratic ones. I feel it's time to do that too. I have 6 quadratic equations we're going to discuss. So they're going to be quadratic. So we have x all over x plus 5, which is set equal to x minus 4 all over x. So we have variables everywhere, but first, before we do anything, we need to restrict our values of x that would make either denominator 0. So if we set x plus 5 equal to 0, you would get x equals negative 5, which means we cannot allow x to be negative 5 because you would get a 0 denominator. And then obviously the second denominator, x equal to 0, that also wouldn't work because you would have a 0 denominator. So as long as x is not equal to negative 5 or 0, we're good. You get either of those solutions, you have to discard it. And in some of these, when it turns quadratic, you could have the normal 2 solutions. You may only have one solution because you have to throw out one of the results, or you could have no solution if you get both of those. So let's do this here. Take the product of your means, which would be x times x. We know that's x squared. That's going to be equal to the product of your extremes, which would be the quantity of x plus 5 times the quantity of x minus 4, which then means x squared is equal to, let's FOIL this, that's going to be x squared minus 4x plus 5x minus 20, which would simplify into x squared is equal to x squared plus x minus 20. Well, right away we notice we can subtract an x squared from both sides to get rid of that. What you'll end up having then is x minus 20 is equal to 0. And then we just solve for that, you'll get x equals 20. Which this actually checks out because 20 is not one of our restricted solutions. So x equals 20 is your only solution. Sometimes you'll only get one solution for these. Not because you got an undefined value, but because you'll have your quadratic terms that end up canceling out. Alright, 5 more and we're done for the day. So I have x minus 2 all over x is equal to x all over x plus 3. Well, once again, set each of your denominators equal to 0 to eliminate any values for which would make the denominator 0, which would make this expression undefined. We set x equal to 0, you get 0 in this denominator, so we cannot allow x to be 0. You set x plus 3 equal to 0, you get x equal to negative 3, so x can also not equal negative 3. So x cannot equal 0 or negative 3. So now set the product of your means here, which would be the quantity of x minus 2 times the quantity of x plus 3, equal to the product of your extremes. X times x is x squared. Now we FOIL, you'll end up getting x squared plus 3x minus 2x minus 6 is equal to x squared, which would then give you x squared plus x minus 6 equals x squared. Well, you can subtract x squared from both sides to get rid of the quadratic term. You just end up with x minus 6 is equal to 0, which would then give you that x equals 6, which is the only solution in this case. So, and 6 is not a restricted solution, so your solution to this is x equals 6. But I think it's good to do some of these quadratic ones so we don't lose touch with quadratic equations. Okay, 4 more problems. We have x plus 1 all over x minus 2 is equal to x plus 5 all over x minus 6. Well, first, let's restrict those values for x that we cannot have that would make either of these fractions in the denominator equal to 0 and therefore undefined. If we set x minus 2 equal to 0, you get that x equals 2. So x cannot be equal to 2. You set x minus 6 equal to 0, you would get x equals 6. X can also not equal 6. So x cannot equal 2 or 6. Let's take the product of the means together, which would be the quantity of x plus 1 times the quantity of x minus 6. Set that equal to the product of your extremes, which would be the quantity of x minus 2 times the quantity of x plus 5. We do the foiling on the left side, you'll get x squared minus 6x plus x minus 6 is equal to, on the right side, x squared plus 5x minus 2x minus 10. Simplify both sides, you'll get x squared minus 5x minus 6 on the left side is equal to x squared plus 3x minus 10 on the right. Well, what do we notice here? We can definitely subtract a common x squared from both sides and get rid of the quadratic term. If you do that, you're left with negative 5x minus 6 is equal to 3x minus 10. Which would then end up giving you, if you simplified this, you would end up getting negative 8x is equal to negative 4. Which would then simply give you that x is equal to positive 1/2, which 1/2 checks out since it's not an excluded solution. So you end up getting the fact that x equals 1/2 for your value. All right, we have x minus 1 over x minus 2 is being set equal to x plus 4 all over x plus 2. Well, first things first, set each of these denominators equal to 0. You'll get the values for which these fractions are undefined. X minus 2 equals 0 would mean x equals 2, so x cannot equal positive 2. X plus 2 equals 0 will give you x equals negative 2, so x can also not equal negative 2. So x cannot equal positive or negative 2. If it does, it's undefined. Let's now take the products of the means times the extremes. The product of the means would be the quantity of x minus 1 times the quantity of x plus 2. Set that equal to the product of the extremes would be the quantity of x minus 2 times the quantity of x plus 4. Do your foiling. On the left side, you get x squared plus 2x minus x minus 2 is equal to, on the right, you'll get x squared plus 4x, x squared plus 4x minus 2x minus 8. Alright, so you simplify the left side, you'll get x squared plus x minus 2 is equal to x squared plus 2x minus 8. Which, again, both sides have a common x squared that you can subtract, which would just give you x minus 2 on the left equal to 2x minus 8 on the right. Which then, if you simplify this, you'll get negative x is equal to negative 6, which can only give you that x equals positive 6. And that solution checks out since it's not a restricted solution. So x equals 6 would actually be your solution to this. Two more and we're done. We have x times the quantity of x plus 5 all over 4x plus 4 set equal to 9/5. Okay, well, good news here. We only have one denominator that has a variable, so set that one denominator equal to 0. So you would set 4x plus 4 equal to 0, which gives you that 4x equals -4, which would have to mean that x equals -1, which means x cannot equal -1. If x equals -1, that makes this denominator equal to 0 and undefined. So now take the product of your means times your extremes. 5 times x plus 5 would just give you 5x times the quantity of x plus 5 equal to the product of your extremes, which would be 9 times the quantity of 4x plus 4. Let's do the distributive property. On the left side, you'll get 5x to the second plus 25x would equal, on the right side, 36x plus 36. Which, let's simplify this now. We're going to have a quadratic equation to solve. Nothing cancels out readily. So you'll end up with 5x to the second minus 11x minus 36 equal to 0. Well, let's see if we can factor this instead of going straight for the quadratic formula. So what are some factors of 1 and 5 and then 36 that'll give us a middle term? We have 1 and 36. It'll give us a middle term of -11. We have 2 and 18, 3 and 6, and then 4 and 9. I'm actually thinking the 1 and 5 and then the 4 and 9. So let's try that. X for the first one, 5x for the second one. So we had 5 times 4, so the 4 would go here. We'd have 1 times 9, so the 9's going to go here. Alright, so we get 5x squared plus 9x minus 20x would be minus 11x minus 36. So this does factor out. So this quadratic equation factors into the quantity of x minus 4 times the quantity of 5x plus 9. Now just set both of these quantities equal to 0. X minus 4 equals 0 would just give you that x equals 4. And 4 is not a restricted solution, so x equals 4 actually checks out. Now how about 5x plus 9 equals 0? That would give you that 5x equals -9, which would mean x equals -9/5. Well, -9/5 is not a restricted solution, so that would also check out. So x in this case has two solutions. You would get 4 and then -9/5. And if you plug either one of these into the original proportion, you would see that both ratios would be in proportion to each other. So x equals both 4 and -9/5. And I'm only briefly reviewing this today. My goal is to help you with what we got coming up here in geometry. If you do struggle with ratios and proportions, I do have lessons on that in the Algebra 1 playlist. They will always be there. You're welcome to check them out. Feel free to check them out. There's no shame in it. They're free to you if you need help. That's why I have them there. But my goal, not to sound this way, is not to reteach Algebra 1. It's just to do a little bit of review. Last problem. We have x minus 1 all over x plus 2 equal to 10 all over the quantity of 3x minus 2. Now both denominators have variables, right? So we need to find the value of those variables that would make the denominator equal to 0 and then restrict those values. First up, if we take x plus 2, set it equal to 0, that's going to give you that x is equal to negative 2, which means x cannot equal negative 2. And then if we take 3x minus 2, set that equal to 0, you would get 3x equals positive 2, which would give you x equals 2/3, meaning that x cannot equal 2/3 as well. So now let's go ahead and do this. Take the product of your means, which would be the quantity of x minus 1 times the quantity of 3x minus 2. Set that equal to the product of your extremes, which would be 10 times the quantity of x plus 2. So FOIL on the left, you get 3x squared minus 2x minus 3x plus 2. That's going to be equal to, distributing on the right, you would get 10x plus 20. Which, let's simplify the left side first. You would get 3x squared minus 5x plus 2 equal to 10x plus 20. Well, none of the quadratic term has no way to cancel out, so we have another quadratic equation to solve. If you simplify this, you'll get 3x squared minus 15x minus 18 equal to 0. Well, do we notice something right away? We can simplify first before we even try to factor. All three of these terms have a common 3, right? If we divide all three of these terms by 3, what it turns into is you get x squared minus 5x minus 6 is equal to 0. That's a lot more pleasant to work with than what you originally had. Now we need to try to factor this. Let's see what we can factor, and I think I have a good idea. This is going to be x and 1, and then x and 6, and then what order should this go in? Let's see, this would be minus 6x plus x would be minus 5x minus 6. Okay. So this factors into the quantity of x plus 1 times the quantity of x minus 6 equal to 0. Now just set both of your factors equal to 0. You would get x equals negative 1. And then you would get x minus 6 equal to 0. That would give you positive 6. And neither of these solutions are excluded. So your two solutions to this proportion are x equals negative 1 and then positive 6. So that's it for this lesson. Next lesson we are going into similar polygons, which will start putting what we've talked about these past two lessons into practice in the geometry arena. So I hope everyone has a good day. Take care.